Hello students and welcome back to the world of Notebook, where math is a path to unlock and understand various phenomena around us. In this tutorial, we will introduce and discuss the topic of quadratic equations. You may ask, actually you should always ask, as to why do we need to study quadratic equations? Well, the answer is very simple. Linear equations alone are insufficient to encapsulate and solve many problems which arise when we analyze problems in geometry. Some real-life issues involving time and speed, money and profit, among many others. Some of these cases, when formulated mathematically, give rise to equations which are squared in the unknown variable, that is, quadratic equations. Therefore, we need to know tools and techniques to solve and analyze this class of equations. Further, as you would study in advanced courses, the equations are components and parts of a bigger set of problems, solving which would demand having a very good understanding of quadratic equations. Let us try to understand that with an example from the game of basketball. When the player throws the ball into the pouch, the path of the ball in air forms a curved line. Now, suppose we want to know the best position of the player and how he should throw the ball so that it ends up in the pouch most of the times. We will use our understanding and some of the concepts of coordinate geometry to understand the path traced by the ball and some ways to find the exact position of the player to maximize scores. We retain the path of the ball and introduce the Cartesian plane to give a mathematical formulation to our problem. Curved paths like this can be studied under the topic of quadratic equations. The general formulation of a quadratic equation takes the form ax squared plus bx plus c equal to 0, where a, b, c are real numbers and a is not equal to 0. A, b and c are called the coefficients and x is the unknown variable. The expression ax squared plus bx plus c denotes a relationship in the variable x. Going back to our graph, it represents a curved path like this. It's a polynomial of the second degree in x. The value of the expression changes as the value of x changes and is shown as the y-coordinate. When this polynomial is equated to 0, it becomes an equation in the unknown variable x. And by writing it in such a fashion, we mean to state that there are some values of x such that the value of the expression becomes 0. Recalling from a study of the Cartesian plane, remember every point on the x-axis implies a value of y-ordinate to be equal to 0. These points are known as the solutions to the equation. They represent the value or values of x for which the quadratic polynomial equals to 0. So, students, there are many such examples where quadratic equations arise as we try to formulate and solve a problem. The shape of the curve is determined by the value of the coefficients a, b and c. We would learn about their relevance in the following tutorials. We suggest that you pause and rewind at every step if you feel confused. Let us now give a formal structure to the definition of solution of quadratic equations. A standard framework helps maintain consistency. Formally, the solution of a quadratic equation means those values of the unknown variable for which a given quadratic polynomial becomes 0. So, if k is a real number and is the solution of the quadratic equation, then substituting k in place of x and evaluating the expression would give us 0. We will discuss the nature and properties of solutions in more details in upcoming tutorials. Let us now briefly discuss the coefficients and their importance. The conditions on coefficients A, B and C are very important in the definition of a quadratic equation, particularly the one which specifies A to be not equal to 0. The word quadratic means squared in Latin. A non-zero coefficient of x squared on left-hand side makes it a quadratic equation. The condition on the coefficients specifying them to be real is also important because then we can try to formulate and analyze the problem in the Cartesian plane, which is the plane of all real numbers. If A is equal to 0, then the equation becomes bx plus c equal to 0. This is a linear equation in x. Recall from our discussion of linear equations. If we plot all the combinations of x and y which satisfy the linear equation, we get a straight line. Now, we are equipped with the definition and specification of a quadratic equation, and we know that it represents curves in the Cartesian plane. Let us spend some time going through the various types of shapes of the curves as determined by coefficients of the quadratic equation. It's a lot more fun than you can imagine. The coefficients are quite powerful in determining the shape of the curve. In follow-up tutorials, we would see how the coefficients also end up controlling the solutions of a quadratic equation. The coefficients A, B and C determine the shape of the curve. We will consider few examples. We see that the coefficients determine 1. Whether the curve intersects the x-axis at all, and 2. The sign of the quadratic polynomial as x changes. We shall now analyze the shape of the curve for specific combination of values of A, B and C. In the first case, case A, we set the value of B and C equal to 0. We illustrate two sub-cases in this category. One where A is greater than 0 and another where A is less than 0. So, we see how the coefficient A changes the curve vertically as its value changes from negative to positive corresponding to A. We now consider another possibility where the value of A is fixed and C is still 0. We shall explore how the curve changes shape as B changes from negative to positive. So we observe that there is a horizontal shift of the curve across the origin. We now consider the third possibility where A and C are fixed. Both are non-zero. We change the value of B to see the corresponding changes in the shape of the curve. We hope that the previous exercise gave you some idea about the relationship of the curve with the coefficients. We shall now rewind a bit and spend few minutes on something we mentioned earlier in the tutorial. As we discussed earlier, quadratic equations arise in many situations. For example, when we are working with areas, situations involving speed and time, situations involving profit and expenses, etc. In each of these situations, we have one unknown variable and some information around it. Using the information provided, when we formulate the situation mathematically, we get a quadratic equation. And finding the unknown variable amounts to solving the quadratic equation. Let us revisit our game of basketball. If we denote x as the distance of the ball from the origin, then let us assume that the expression 5x minus x square gives the vertical position of the ball with respect to the origin. So if x equals 2, then the vertical distance of the ball The y-coordinate is 6, which is obtained by substituting the value of x in the quadratic polynomial, and the point is shown on the curve as p coordinates 2, 6. So students, we saw an example where formulating our requirement mathematically led us to the formulation and hence solving a quadratic equation. We hope you enjoyed watching this tutorial and are excited to learn about more quadratic equations in the following tutorials. Keep watching, keep learning, stay curious, stay hungry. See you soon in the next tutorials.